Hi friends, let's revisit problem 2364, count number of band pairs. So in this video, we're going to share two formats of solutions. The first one is based on dictionary and check. So this method actually follows the same line of idea for Leetcode 2426. And the second method is a direct count solution. So I will first read through the statement of the problem to digest the requirement, and then we do analysis and share the code. The statement of the problem is very short. It says that given an integer array called nums, so it defines a bad pair ij if the following two conditions hold. First, I is less than j, and second, the difference of indices does not equal to the difference of the corresponding numbers. So we are required to return the total number of band pairs in nums. So here are two examples. So in example 2, so the output is 0, so which is very easy to check. And in example 1, so the output is 5. So in the explanation, it lists all the valid band pairs. So before we look at the analysis, so let's also look at the constraints. First, the nums array has a length bounded below by 1 and bounded above by 10 to the power 5. So this first constraint actually defines the problem size. The second constraint is on the range of elements in the nums list, so which is not negative and bounded above by 10 to the power 9. So with that said, we are ready to look at the analysis. So here the two methods are dict and check, and the second is dict direct count. So let's look at each of them one by one. So first, let's look at the dictionary and check method. So here, the condition for this problem, the main condition is given by equation star. So equation star actually is mathematically equivalent to equation double star. But our viewpoint changes after we do this transformation. The reason is that, so in double star, so if we look at the two sides, actually I and J are decoupled. So because of this decoupling property, so we could consider the difference list. So in other words, we consider this aux. So we can consider the number minus the corresponding index. So that is y minus I for I and y in the enumerate of this nums. In other words, we track the number and its index. So when we look at an index in aux, so then it corresponding to an index j, right? What we want to do is to find among the previous indices I, how many of them can form band pairs with G. So to do this, actually we can use a dictionary. So this is very easy or routine. So here let's give a quick walkthrough for example 1. So in example 1, so the nums is given by this. Then if we consider the difference of num elements minus their indices, we get 4 minus 0, 1 minus 1, 3 minus 2, and 3 minus 3. So we get 4, 0, 1, 0. And then if we look at the first index, so no less indices, so no valid pair, so we get 0. And if we look at 0, right, so previous we just have one index, that is 0, so we have 0, 1. So this is a good valid band pair, so we add 1. So if we look at this 1 here, so previous we have two indices, so corresponding to 0 and 1, right? So there are two band pairs, so we add 2. So similarly, if we look at 0, so if we look at 0, to the left of 0, there are 3 indices, but one of them corresponds to 0. So we get 3 minus 1, that is 2. So we add another 2. So in total, it's 5. So this is the first method. So now let's first write a solution using the first method. So this transformation or decoupling is exactly following the idea of problem 2426, or we can see they are similar, right? We want to use the decoupling property. So for this solution, so we're going to use dictionary and check. So this actually can be very short. So let's write it with some redundancy. So first, I'm going to initialize a result variable to be 0. So this is for counting, and then we're going to initialize a dictionary. So you can do this to emphasize it's a dictionary. And then we're going to iterate over these nums because we want to consider this aux. In other words, we want to track the indices. So what we're going to do is for I, y in enumerate. So we're going to use this function as nums. And then if we look at this y, then its index is I. It means that to the left of y, there are I indices, smaller indices, right? So what we are going to do is that when we look at each of the I and y, so what we're going to do is that we want to increment the result. So the dictionary will store the previous difference and their counts. So what we are going to do is that, so this is a total smaller indices in front of I, right? So then we want to check how many indices correspond to the same difference. So we want to subtract that difference, right? So we can do this by get y minus I. So if this y minus I is not in the previous dictionary state, so we're going to make it 0, right? So this way we added the band pairs before this number y. Then we're going to update this dictionary. So what we're going to do is update this y to be, so basically we want to add 1, but we are not sure if y minus I is a key of the dictionary. So what we are going to do is get, so y minus I. So if y minus I is not a key, so we're going to have a default value 0. Then we add 1. And after this for loop, we're going to return results. So that's actually a full solution to this problem. So let's first do a special case check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So if we compare this format of solution, so actually it's no difference or essentially the same as the two-sum problem. So it's fair to say, or we can say that this can be regarded as an extension of the two-sum problem. So this is the one solution format. So now with the intuition we gained, now let's look at the second method. So we're going to use direct count. So the second method is that we assume the length of this nums is n. So we still use the aux above, right? Because this is the main requirement or main condition. So we want to find the unique value and their corresponding frequencies. So then all the available pairs, so ij with ij inbound and I is less than j, is nothing but c, and we choose 2 out of n because the order is important, so we just choose. So this is n times n minus 1 over 2, right? So the possible pairs are n times n minus 1, but if we take care of the pairing because we want I is less than j, so this is divided by 2. So this is the total pairs, and then we want to use this number minus those pairs ij such that they ij are inbound and the double star is not satisfied. In other words, they produce equality, right? So in this case, we just need to subtract. We do c and choose n choose 2 minus. So from each of the frequencies, choose 2. So there's a possibility that the frequency is 1, right? But if the frequency is 1, but we choose 2 out of 1, so we get 0. So we minus nothing. This still works. So let's look at example 1 to digest. So this is the nums list, and this is the aux as above. So 4, 0, 1, 0. So the count is that 0 appears twice, 1 appears once, and 4 appears once. Because the length is 4, so the total pairs we want to look at is 4 times 3 over 2, that is 6. In other words, choose choose 2 out of 4. Then the two differences are, there are two frequencies of 1, right? So let's see, this 1 appears once and 4 appears once, so we can ignore that. So we just need to choose 2 out of this 2 and minus this one. So we get C, and as 2 choose 2, we get 1. So 6 minus 1 is 5. So this is another format. So this format actually is also easy to write, but the code is so we can write it in a very short fashion, but let's write with some detail. So we are going to mark this one as V1. So for this, let me first get the length of nums. So let's work step by step. And then we are going to make a count, right? So count is nothing but collections counter. So you can use a dictionary to traverse the difference list, or you can just use the counter. So what we are going to do is that y minus I for I, y in enumerate nums. So this way we get the frequencies, the unique values and their frequencies. Then what we're going to do is let's first write the total pairs. So actually we do not need to do this, but let's write with details. So total pairs is n times m minus 1 integer division by 2. And then we are going to do some subtractions. So for k and v in, so let's just use v, right? So for v in count values. So these are the frequencies. If v is greater than 1, then what we are going to do is that total pairs minus v choose 2, right? So v minus 1 divided by 2. And then finally we just need to return the state of total pairs. So that's the second solution format. So now let's look at check. Yeah, it passes the first case. Now let's look at the generic case. Yeah, that's about it. So in this video, actually we shared two formats of solutions. So one is the direct count. So this is more specific to this specific problem itself. And the first method is what we are going to emphasize. It actually can be followed from Leetcode 24-26, or we can regard it as an extension of the two-sum problem. So actually the dict and check is a general method. Sometimes we use set and check. So this line of idea can solve a bunch of problems. So with that said, I guess that's about it for this video. Thank you.